Today we shall discuss about an important chapter in coordinate geometry, circles. So let us start with the basic definition. Let's C be the center. You call it as H comma K, and you take a point P of X comma Y. Before finding the equation of circle, let us discuss basic definition of a circle. That is, circle comes under the locus concept, the locus of a point which moves such that the distance from a fixed point to the moving point always remains constant. The distance from a fixed point to the moving point always remains constant. Such point's locus is nothing but a circle. And this fixed point is called center. And this fixed distance, we call it as what? Radius. So now, P is always moving in a plane, in a locus, right? The distance from wherever the position of the P may be, it remains always constant. That constant distance, we call it as what? Radius. And locus of P is the circumference of a circle. Let P of X comma Y be a point in the locus, moving point in a plane with the set of given conditions. Let us find out the equation of a circle. I am going to start. Let P of X comma Y be a point on the circle, whose center is C of H comma K and radius is equal to R. By definition, CP is equal to R. CP is equal to R. Why? It's a fixed distance. Now, this is given by X, that is H minus or else X minus H whole square plus Y minus K whole square is equal to R. By using square root of distance formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square is equal to R. Now squaring on both sides, this becomes x minus h whole square, y minus k whole square is equal to R square. This is the equation of a circle having a center H comma K and a radius R, and which is a second degree equation in X and Y. If I expand, suddenly we are going to get this one as x square plus y square minus 2hx minus 2ky plus h square plus k square minus r square is equal to 0. Certainly you can very well observe, now it's a second degree equation X and Y. And meanwhile, one of the important observation is coefficient of x square and the coefficient of y square are equal. The first and foremost thing for any equation, secondary equation, to represent an equation of circle, compulsory coefficient of x square must be equal to coefficient of y square. So therefore, this hereafter, this also represents the equation of a circle having a center h comma k and radius r. Now I want to find out the standard equation of a circle. What is the standard equation of circle? A circle having a center 0, 0 is always taken as a standard circle. You call this equation as a 1, put put h comma k is equal to 0 comma 0 in 1, then 1 becomes implies that is x square plus y square is equal to r square. This is nothing but an equation of a circle having a center 0 comma 0 and radius. So therefore now here also you can very well observe the coefficient of x square and the coefficient of y square are always equal. Here it is equal. Hence we call it as any circle having a center 0 comma 0 and radius r is taken as what? Standard equation of a circle. Now I want to show that, yes, now you can take this as the equation x square plus y square plus 2zx plus 2fy plus c is equal to 0. This also represents an equation of a circle having a center minus z comma minus f and radius is square root of g square plus f square minus c. Before telling it as whose center as minus g comma minus f, first of all we have to reduce this equation in a what? Either x square plus y square is equal to r square or x minus h whole square plus y minus k whole square is equal to r square. Now what I do is, from this x square plus y square plus 2zx plus 2fy plus c, I want to make this as a perfect square. Now what I do is add and subtract, that is g square plus f square. Therefore g square minus f square is equal to 0. Now group the what like terms, x square plus 2zx plus g square and one bracket plus y square plus 2fy plus f square in one bracket, transfer c square to what? RHS. So therefore, and meanwhile this g square also, so that is minus c, this is minus c, that is g square plus f square minus c. So therefore I can write this one as a perfect square, x plus g whole square, that is y plus f whole square is equal to what? Square root of g square plus f square minus c whole square. I can arrange this in the form of x minus of minus z whole square, y minus of minus f whole square is nothing but, that is g square plus f square minus c whole square. Now this equation is in the form of, you call this as equation star. Now star is in the form of x minus h whole square, y minus k whole square is equal to r square. So therefore you can compare this equation with this equation. We get center as h comma k is equal to minus z comma minus f and radius r is equal to g square plus f square minus c. G square plus f square minus c. Yes. Now if I consider this equation as 1, so this can represent, now we have proved this equation represents a what? Circle. Why? Because coefficient of x square and the coefficient of y square are equal and having the radius g square plus f square minus c. Now we have a discussion. Case 1. What is case 1? If z square plus f square minus c greater than 0, z square plus f square minus c greater than 0, then one represents a real circle. One represents a real circle. Now if I go for case 2, if z square plus f square minus c now is equal to 0, then one represents a point circle, or we can also call it as limiting point. Then I go to third case, case 3. If z square plus f square minus c less than 0, then one represents a imaginary circle. So therefore, now we come across 3 cases under the what? General equation of a circle. Any circle in a general form is represented by x square plus y square plus 2zx plus 2fy plus c is equal to 0. It represents a circle whose center is minus z comma minus f and radius square root of z square plus f square minus c. So, and it represents a real circle when g square plus f square minus c is greater than 0. Why? Because this is the quantity under the square root. If this is to be defined, that quantity must be always positive. So, therefore, g square plus f square minus c is greater than 0, then one represents a what? Real circle. Next, if g square plus f square minus c is equal to 0, then one represents a point circle or a limiting points. Next, if g square plus f square minus c less than 0, then one represents a what? Imaginary circle. Let us start to understand another equation which also represents an equation of a circle. The equation ax square plus 2hxy plus by square plus 2zx plus 2fy plus c is equal to 0. Okay, this also represents an equation of circle. We have to show that. So, how to do that? Now, we have to show that the coefficient of x square and the quotient of y square must be equal. And this is also second equation. This also represents an equation of circle if first one, coefficient of x square is equal to coefficient of y square, which implies a must be equal to 0, and the second equation, the second condition is coefficient of xy is equal to 0, which implies h is equal to 0. So hereafter, this also second equation to represent a what? Circle. As we come across earlier, x square plus y square plus 2zx plus 2fy plus c is equal to 0, which also represents the equation of circle having a center minus z comma minus f. Even this also represents the equation of circle, provided a is equal to b and h is equal to what? 0. H is equal to 0. Next, we shall go for an understanding the basic properties of the circle. So the equation x square plus y square plus 2x plus 2fy plus c is equal to 0 represents a circle. So here there are three independent constants. You call this as equation 1. In equation 1, there are three independent constants. So it means that hereafter, to find the equation of any circle, you must have the 3 points on the circle. So why? Because there are 3 unknowns. To find the 3 unknowns, there must be 3 equations. Certainly, there must be 3 points on the circle. So therefore, hereafter, to find the equation of circle, the first method is you must be given with what? 3 points, which must lie on the circle. The second method, since we have the 3 unknowns, he must give either three tangents. Why? When any line is said to be a tangent to the circle, we are going to understand in the future. That is, when any line is said to be a tangent to the circle, a radius is equal to perpendicular distance. With that data, we must have 3 tangents to find what? 3 unknowns, G, F and C. The third method is he must give 2 tangents and he must give 1 point, because 2 tangents touches a circle, we get 2 equations. And third point, a point lies on the circle, or circle passes through the point, we get what? 3rd equations. So therefore, hereafter, to find the equation of circle in a general form, there are 3 independent constants. To find the 3 independent constants, you must have 3 points on the circle, or 3 tangents to the circle, and 2 tangents and 1 point. So therefore, now we understood how to find out the equation of a circle in a general form, having 3 independent constants. Next, a circle. Now, first of all, the basic properties. This is a chord. AB is a chord. So this AB, the A and B are the 2 points on the circle. The line joining of these 2 points, we call it as a what? Chord. Next comes about secant. Now this is also a what? A secant line passing through the point P and cuts the circle in what? 2 points. So therefore, chord, it joins only 2 points on the circle. A secant line, this is the line passing through the point P, which also cuts the circle in 2 points. Those 2 points are lying on a circle. This is called what? Secant line. Next comes about, so this is a chord. This is the longest chord, means maximum length. Means any chord having a maximum length, we call it as aptly the diameter of a circle. The diameter of a circle divides a circle into 2 equal parts. two equal parts. This is above one is a semicircle, this also semicircle. Whatever the area is bounded here, the same area is also bounded below this. So therefore, now every diameter is a chord, but every chord is not a diameter. So why? Because a chord having a maximum length or else a longest chord, we call it as what? Diameter. Hence, every diameter is a what? Chord, but every chord is not a diameter. Yes, when AB is a diameter, the midpoint of the diameter is the center of a circle. Is nothing but a center of a circle. Yes, this is a diameter. Next, I go to the series. Now this is the chord. When this is a chord, yes, P is a point on the circle. This is a major segment. Major segment. So therefore, when this is major segment, P is a point on the circle. The chord which subtends an angle theta at the point P of the major segment is theta. Then it always subtends almost double the angle at a point P. We call it as what? Theta. This is center. I mean, the angle subtended by the chord at the center of the circle is 2 theta. Then the same chord subtends an angle theta at any point on the circle. So therefore, when this is 2 theta, this is what? Theta. Next, if you take a chord, the perpendicular bisector of a chord always passes through the center. Always passes through the center. The perpendicular bisector of the chord always passes through the center. And this is a midpoint and also perpendicular. So therefore, these are the some basic properties of a chord in the circles. Next, we shall make a move to understand the different types of circles. The very first one is the equation of a circle having a of x1 comma y1, b of x2 comma y2 as the extremities of a diameter. Extremities of a diameter. Now I start. Equation of a circle. Equation of circle having a of x1 comma y1 and b of x2 comma y2 as the ends of a diameter is x minus x1 into x minus x2 y minus y1 into y minus y2 is equal to 0. So therefore, I can also write, if you multiply this, I can also write this is, that is x square plus y square minus x into x1 plus x2 minus y into y1 plus y2 plus x1 x2 plus y1 y2 is equal to 0. This is also the equation of a circle having extremities of a diameter as x1 comma y1. This will have a fast approach while doing the objective problems than that. Okay, now how to this one is, now the thing is, for this what I do is, this is a circle having, that is a of x1 comma y1, a of x1 comma y1 and b of x2 comma y2, x2 comma y2. Let us consider p of x comma y, be a point on the circle. Be a point on the circle. You take like this. Now, one of the important property we come across already in the lower classes, the angle in a semicircle is always 90 degrees. The angle in a semicircle is always 90 degrees. So therefore, this is nothing but a semicircle. Angle at this point is a right angle or 90 degrees. Now I start. Let P of x comma y be a point on the circle, having a of x1 y1, b of x2 comma y2 as ends of a diameter. Now, by definition, angle APB is equal to 90 degrees. Angle APB is equal to 90 degrees. So therefore, I can write slope of AP into slope of BP is equal to minus 1. Product of the slopes is equal to minus 1. Why? Since these two are the perpendicular lines. So therefore, I can write now slope y2 minus y1 by x2 minus x1. So therefore, it is y minus y1 by x minus x1 into y minus y2 by x minus x2 is equal to what? Minus 1. Cross multiply, you get y minus y1 into y minus y2 is equal to minus of x minus x1 into x minus x2. Transfer to this side, you get this one as x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. This represents an equation of circle having x1, y1, x2, y2 as ends of the diameter or extremities of a diameter. If you multiply each brackets, definitely we are going to get the circle equation having ends of the diameter x1, y1 in the form of x square plus y square minus x into x1 plus x2 minus y into y1 plus y2 plus x1, x2 plus y1, y2. Yes, this is the juncture where we have to discuss its applications in comparison with calculus maxima, minima. Here is now this is the equation of circle having x1, y1, x2, y2 as the ends of a diameter. Now this same question we can also constructed, we can also ask, you can also be asked in the examination as find the equation of circle passing through x1 comma y1, x2 comma y2 having a minimum area or least radius. Again, find the equation of a circle passing through x1 comma y1 and x2 comma y2 and having minimum area or a least radius. Nevertheless, this equation represents a circle having a minimum area or least radius. So therefore, now if I take the circle passing through, now equation of circle having a of 2 comma 3 and b of 4 comma 5 as ends of a diameter with ends of diameter is dash, or the other way, equation of circle passing through a of 2 comma 3, b of 4 comma 5, and having minimum area or least radius is dash. Now you take this as x1 y1, you take this as x2 y2. Now equation of circle is x square plus y square minus x into x1 plus x2 minus y into y1 plus y2 plus x1 x2 plus y1 y2 is equal to 0. So therefore x square plus y square minus 2 plus 4, that is x into 2 plus 4 minus 5 plus 3 into y plus x1 x2 8 plus y1 y2 plus 15 is equal to 0. So therefore I can write x square plus y square minus 6x minus 8y plus 23 is equal to 0. This is the equation of circle having a of 2 comma 3, b of 4 comma 5 as the ends of a diameter. Okay, ends of a diameter, or in other way, the equation of circle passing through a of 2 comma 3 4 comma 5 and having minimum area is given by x square plus y square minus x into x1 plus x2 minus y into y1 plus y2 plus x1 x2 plus y1 y2 is equal to 0. Or else we can also write in the form of x minus x1 plus x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. So this represents the equation of a circle AB as a what? Ends of a diameter. Yes. Now we understood how to find out the equation of a circle with ends of a diameter, or the equation of a circle passing through what? x1 comma y1 and x2 comma y2 having a minimum area or a least radius. Yes. Up to now we come across about the equation of a circle passing through 2 points and having a minimum radius. That is called the equation of a circle with having ends of a diameter. Now I told in the general equation x square plus y square plus 2zx plus 2fy plus c is equal to 0. There are 3 independent constants. They are z, f, c. To find g of c, we must have the 3 unknowns, 3 points or 3 tangents, 2 tangents and a 1 point. So in context of that, so hereafter whenever 3 non-collinear points are given, only one circle passes through them. As I told, we need 3 points. Those 3 points must be non-collinear. So therefore, now when 3 points are given, equation of circle passing through 3 points, that is a of x1 comma y1, b of x2 comma y2, c of x3 comma y3 is given by this is x1 y1 x2 y2 x3 y3 1 1 into x square plus y square plus we can also write c1 c2, it's a c3. This is y1 y2 y3, next 1 1 1 into x plus I can also write this is x1 x2, that is x3, that is c1 c2 c3, this is 1 1 1 into y plus I can write this one as x1 is x1, it is y1 c1 x2 y2 x3 y3, c2, c3. This is equal to 0. So therefore, this represents a equation of circle passing through how many points? 3 points. Rather than this, instead of this becomes a bit laborious and tedious. The student to remember this better. Go for the what? General equation of a circle. X square plus y square plus 2zx plus 2fy plus c is equal to 0. Take it as equation 1. Passing through this point, you get one equation, say called as 2. Passing through second point, you call it as equation 3. Passing through this point, take it as equation 4. Solve 2, 3, 4. 3 unknowns, g, f, c. You get what? 3 equations. That gives 3 unknowns, 3 equations. That gives the values of what? G, f, c. That also gives equation of a circle passing through how many points? 3 non-collinear points. Okay. Now, when the 3 points are given, this is one method. The another method, what I told just now is, the another method is also there. You call it as is given by. Yes, now first consider let the equation of circle be this is second method, be x square plus y square plus 2zx plus 2fy plus c is equal to 0. So you call it as what? 1. Now 1 is passing through a of x1 y1. 1 implies x1 square y1 square. This is 2zx1 2fy1 plus c. You call it as 2. Then similarly, this is passing through b of x1 x2 y2. This implies x2 square plus y2 square. This is 2zx2. This is 2fy2 plus c is equal to 0. Next, this also passing through c of x3 y3. This is nothing but x3 square y3 square 2zx2 plus 2fy2 plus c is equal to 0. 3, you call it as 0, you call it as 4. Solve, yes, solve, come on, 2, 3, 4, we get what? 3 unknowns, g, f, c. After finding them, you substitute the equation 1. That gives the desired equation of a circle passing through 3 non-collinear points. This is the second method. What first method I told? Passing through 3 points. That is x1 y1 1, x2 y2 1, x3 y3 1 into x square plus y square plus c1 c2 c3 y1 y2 y3 1 1 1 into x plus x1 x2 x3 c1 c2 c3 1 1 into y plus x1 y1 c1 x2 y2 c2 x3 y3 c3. That is equal to 0, where in that case ci is equal to minus of xi square plus yi square. If I is equal to 1, it's a x1 square plus y1 square. If I is equal to 2, there x2 square plus y2 square, c3 minus of x3 square plus y3 square. That is first method. Second method is this. Consider the general equation. This general equation is passing to 3 points. 3 equations we have. Solving them is the what? We get 3 independent constant g, f, c. G, f, c. There is another method. What is it? Third method. What is the third method? The third method is equation of circle. Equation of circle passing through the point of intersection of the circle S is equal to 0 and the line L is equal to 0 is given by is given by S plus lambda L is equal to 0. S plus lambda L is equal to 0. How? This is the figure approach. This is one circle. This is S is equal to 0. This is another line L. This line can be a chord or a longest chord. So therefore, now this is a circle passing through the point of intersection of the circle S is equal to 0 and L is equal to 0. This is given to be S plus lambda L is equal to 0, where lambda is a what? Parameter. Yes, I told this application, yes, this application S plus lambda L, we can also use to find the equation of circle passing through 3 points. How, sir? Yes, in an elaborate way, you take a of x1, y1 and b of x2, y2 as the ends of a diameter. We get what? We get S is equal to 0. This is the circle having a, b as the ends of a diameter. We got S. I want, this is taking this as A, taking this as what? B, correct or not? Okay. So therefore, now A and B. Now write down the equation of line AB. Equation of line AB we get as what? L. After finding this, you write down. But lambda is an unknown. To find lambda, you substitute the what? Third point, or that point, x3, y3. To find the lambda, if you substitute x3, y3, after getting lambda, you substitute here. That gives the third method to find out the equation of a circle passing through how many points? 3 points. Yes, today we come across how to find out the equation of a circle passing through 3 non-collinear points. The first method is, yes, come on, I told, that is x1, y1, 1, x2, y2, 1, x3, y3, 1, determinant x1, y1, 1, x2, y2, 1, third row, x3, y3, 1 into x square plus y square plus determinant first row c1, y1, 1, second row c2, y2, 1, third row c3, y3, 1 into x plus determinant again x1, c1, 1, next second row x2, c2, 1, next third row x3, c3, 1 into y plus x1, y1, c1, x2, y2, c2, x3, y3, c3, determinant is equal to 0, where ci is equal to minus of xi square plus yi square. That's the first method. The second method is, consider the general equation of a circle in the form of x square plus y square plus 2zx plus 2fi plus c is equal to 0. Call it as 1. Passing through first point, one equation. Passing through second point you substitute in that circle, you get second equation. Substitute the third point, see in the what? Third circle equation, you get third equation. Solving them, we get 3 independent constant. They are z, f, c. That's the second method. The third method is the equation of a circle passing through the point of intersection of the circle S is equal to 0 and L is equal to 0 is given by S plus lambda L, where lambda is a parameter. Then how to find out S? Take it as what? Ideal case. AB as a diameter. That gives the equation of circle. It's a line. Take a line as a AB. After writing S plus lambda L is equal to 0, we are left with C of x3, y3. Substitute in that. That gives the value of the unknown lambda. After finding the lambda, again you substitute in what? S plus lambda. That gives the required equation of a circle passing through the 3 points. So today we come across the different forms of what? Circle, and the properties of a circles, and also how to find out the equation of a circle passing through how many points? 3 points.